Just know you are being recorded at the moment. Don't worry, I'm only recording the screen like I normally do. So this set of notes is going to end our first LAQ. How do we name and write formulas of ionic compounds? Now, we should have some familiarity with ionic compounds. We always know from the last unit, we already know it's a metal and a non-metal are bound to each other. We know that the electrons are transferred, so no one's sharing anything. And last two classes, we talked about our naming of ionic compounds. When I'm looking at a binary, meaning two atoms, it's always, the name is going to be written, the metal, whatever the metal is, non-metal followed behind it. We're going to cut off the end of the non-metal and add IDE. That should be familiar to you. It's what we worked on last time. And we were looking at an ionic compound with a polyatomic ion. That's just many atoms, one charge. Our naming scheme was just the metal and then the polyatomic ion. Whatever the name of the polyatomic ion, that's just what we named it. Easy peasy lemon squeezy. If I had an example, do I have a blank piece of paper? Let me get a blank piece of paper real fast. Thought I had some over here, but I got them all stacked over here. Let me just slide this up a little bit. If I had something like, let's see, MgI2. What's my metal here? An MgI2. Magnesium. What's the I represent? What element? Iodine. But I'm not going to write iodine. I'm going to write what? It's not going to be iodine. Iodine. What am I going to do to the end of iodine? Cut it off and add IDE. So MgI2 is going to be magnesium iodide. If I did another one, let's do Al3 S2. What's my metal here? Aluminum or aluminium if you're special. And by special, I mean from across the pond. What is the end of that name going to be? Aluminum what? Close. Sulfide. Sulfide's the polyatomic ion, so be careful with that. But notice how I don't care that for this formula, I needed 3 aluminums and I needed 2 sulfurs. It wasn't trialuminum disulfide. It's just metal, non-metal. Ionic compounds are the easiest ones to do. It's always metal, non-metal. But if I choose something like MgSO4, what's that name going to be? What's the metal here? Magnesium. What's the polyatomic ion? You just took a quiz on it, guys. I hope you know this. Is it sulfate or sulfite? Sulfate. Do I have my atomic ion sheet? I do. Shall. When in doubt, let's grab my polyatomic sheet. Sulfate. If I had, let's do BECN2. What's that name going to be? BECN2. Beryllium, for sure. What's the CN? Starts with a C. Starts CY.
What was it?
Cyanide. CN minus 1 is my cyanide. Beryllium is the top of my alkaline earth metals column. It can only give me a +2. Cyanide can only give me a -1. So therefore I need 2 cyanide ions for 1 beryllium cation. So let's talk about, now, notice how we only talked, if I draw up my periodic table real fast. I only talked about group 1 and group 2. But I know all my metals stretch all the way over. And I'm missing out about all these right here. My transition metals, right? What about them? Do they form ionic bonds? Absolutely. The thing is that when they form ionic bonds, things are a little weird. And that's what we're going to talk about today. We talk about ionic compounds and transition metals. The first thing we're going to find out is that transition metals don't just form one cation. If I look at magnesium, magnesium always forms Mg+2. It's in group 2, always going to want to get rid of those 2 electrons. Because the transition metals have those d orbitals, they can be stable at different versions. Here are some more common ones. Chromium, number 24 in the periodic table, comes in 2 main flavors, either as Cr2 or CO3. Cobalt, if we take a look, where's cobalt in the periodic table? I'm looking for CO. Where are you at, cobalt? I can't see you, cobalt. Anybody see cobalt on the periodic table? Number 27.
I know, but I'm trying to get it done.
Comes also in 2 main flavors, CO2, CO3. Copper's right there, number 29. Iron's 26. Lead is not one of the periodic tables, but it is one of those weird ones that are so large it can form different things. Mercury, number 80. Tin, another one of ours that's too big, it can form different stuff. Will come in multiple different flavors, multiple different shapes. The key thing to look at is that the ion formula and these Roman numbers, Roman numerals next to them. Like we said before, transition metals have more than one possible charge. So we have to indicate that in the compounds named. And how we do that is we're going to write whatever the charge is as the Roman numeral. So Cr+2, cation Cr+2 is chromium 2, parentheses 2, end parentheses. Cobalt 3 plus cobalt, parentheses, the numeral Roman numeral 3, close parentheses. We're going to use this charge that's written here to balance our equations, just like we did before. Nothing's changed. It's just that sometimes our transition metals come in different flavors. That's all it is. So on the back of your paper, let's do one together. Cobalt 2 iodide. We want to write the formula. There's an M before the U. Cobalt 2 iodide. My question to you, what anion does iodine produce? Iodine being the nonmetal, always going to produce a minus what anion? Was it? -1. All right. Now remember, whatever the cation's charge is in parentheses in Roman numerals. So cobalt 2, what's the cation going to be? Plus what?
2.
Plus 2. All right. So if I'm wrapping up this formula, do my charges cancel each other out? No. 2 minus 1 gives me +1. So do I need more cobalt or do I need more iodine? I need another iodine. 2 minus 2, is those charges cancel each other out? Yeah. So let's see COI2. Same thing we were doing before. The only difference is that cobalt comes in two main flavors, CO2 or CO3. We have to indicate which one it is. So if I give you just the name of the formula, name of the compound, you should be able to tell me what the cation is. Once you figure out what the cation is, you should be able to tell me how many anions and cations you need to make a formula. Now, we're going to start off here, and chromium sulfate is where things are going to get a little tricky. Because now I got to work a bit backwards, right? Because I know chromium, as I saw before, chromium comes in two main flavors, a +2 or a +3. These are the main two types of cations chromium will form. It can form a +1, a +4. Let's see, where are you at, chromium? Chromium is Cr, so we do 1, 2. Yeah, you go all the way from +1 to like a +6. If I'm shredding all those valence electrons, so I got my 4ds and my 3d4, man.
No, I gave you.
That's fine. I'm moving forward with it
Okay, why?
because I don't need it at the moment. So I know chromium. If I remember my shorthand for its electron configuration, I'm going to see chromium is AR 4s2 1, 2, 3, 3d4. So I can lose 1 valence electron, 2 valence electrons, 3, 4, all the way to 6. That's how many valence electrons chromium can lose. But it likes to only form Cr +2 or Cr +3. And am I expecting you to memorize what are the major flavors for chromium there are? No, because I can pull out which one it is by looking at the formula, by looking at the name. Sulfate. Someone tell me the polyatomic ion in charge for sulfate. What's the polyatomic ion for sulfate, guys? Starts with an S.
Sulfur.
There's an O. 4. What's the charge?
Is it?
Not 1. -2. Which chromium lines up best? CR2 or CR3? CR2. If I have the name, I can write the formula. If I have the name, I can write the formula. That's what we're going to be doing today. Okay? So let's focus first on the easy stuff, and then we'll come back and work on the harder stuff together. Sound good? All right. So let's look at the first one together. So this is on your piece of paper. I just grabbed the 8 of them and I put them here in the slide. Let's look at number 1 together, and then we'll give you 10 minutes to work on the other ones by yourself. So, I see iron sulfide. Now, if I see an IDE, am I expecting a binary compound or a polyatomic compound? Binary. My ides are my binary, right? So, excuse me, I have for this one, bada bada boom. So we have sulfur as my anion. What's my charge of my anion for sulfur? -2. Iron parentheses 2. Which charge do you think my iron has? +2. Do my charges cancel each other out? So for 1 iron, I have 1 sulfur. That makes sense? Be mindful of how your word ends, because phosphide would be a binary. Phosphate tells me that's a polyatomic ion. Nitride tells me that that is a binary. But chlorate tells me that's a polyatomic ion. If it helps, you might want to have your polyatomic ion sheet out right now. I'm going to give you 10 minutes to answer the other 9 or the other 7. I'll be coming around checking on you. Let's fix that.
There's two because you're added to, or
Mg is magnesium. Manganese is Mn. That's when there's a fluid.
okay. So now we do it. Yay.
You're right with the chart.
Okay. So. Oh, this thing. This is. I don't know what that is. No, I do, but I don't. This is fine. Maybe you should try it. Maybe it's plus it's not you put the peel down. Six. That's a little bird. Five to 5, 10. Wait, that's not. Maybe this one. Okay, maybe it's not bad. Huh? Maybe it's not bad. No, it's not good. This one's easier. Copper. Where's copper? That's good. Copper. Right here. Okay, you. What's that? Oh, so it's fine. What's the
Too much
Sure.
That's it.
I tried. So, we're copper. Oh, I'll just put this one. And then there is nitrate. Oh, it's nitrate? I think so. So that would be -3. Let's see. So you have to add 2 more. That's like a way to see it. See it copper. You watch this school this week? No, I've never been into sports. Me too, I just watched that. You just watched halftime? What's halftime? It's like, it was that. Okay. I just do it for that. Yeah, I don't like football. I was supposed to do it for like one extra credit assignments. I'm working on it. I need that extra credit. Okay. So, okay, so what about I know, like, I'm so, like, okay, so what does that equal to? Like, CU, copper. So that'd be like, should we do CU3 or CU2? That's or 1. Why would you do 2? Huh? Because it's how much you have on. Write it on 1. Where's the 2? It's like, oh, what if we don't do it again? Because they're both equal. We just put CUP. No. It's whether or not you add on to it. have one. It is. It's CO39. And use it. I'm so scared. I don't know what it is. But you said N. You said 2 now. No one heard that. No one heard that. I said do 3. So actually, that's fine. We just wanted to say that. What's he said? Keep it consistent. Okay, but whatever. No one heard that. No. I already said you too. Let's see. Yeah. That makes more sense. I really have no clue what I'm doing. What is number 8? Huh? Okay. So, am I polyatomic? This one. Is that 2? Yeah. Yeah, I know. Alright, so we know. It has to be.
Everything else looks to be on the right side. We just have to be careful of those 4 that don't fit the memorized 5/8. All right, guys. So let's talk about 3 of them. Excuse me. I want to talk about 3 of them. I want to talk about 3, 5, and 8. So, a lot of you guys are doing really good with this one. So, copper, what's the cation for copper here? Cu plus 1. How do I know it's just 1? See the charge right there. Nitride is going to form which anion? N minus what? N minus 3. Therefore, I need 3 coppers, 3 copper cations to cancel out the nitrogen's anion. So Cu3N. Feeling good? All right, let's look at cobalt. Cobalt, that is CO. What's the charge on cobalt 3? Plus 3. Perfect. And if I look at chlorate, it's 4. ClO3, how many? What's the charge on chlorate? Minus what? Minus 1. So my question to you, cobalt chlorate, is that going to be written as COClO3, or is it, that's option number 1, or COClO3 parentheses 3, option 2? What's the correct answer?
Is it 2?
2. 2 is the correct answer. Because if you left it as 1, you're telling me that there's 1 cobalt, 1 chlorine, and 33 oxygens. If you have more than 1 polyatomic ion, you have to put the polyatomic ion in parentheses. Notice that when I had multiple metals, I just put the number next to it. Because I'm just saying there's 3 coppers. Down here, I'm saying that there's 3 chlorates. The polyatomic ions are treated as one thing. That's why we put those plural numbers in parentheses. So if I'm looking at 5, so it's CO parentheses ClO3, 3. Be careful about that. Now I chose number 8 because a lot of us were getting a little mixed up. I saw a lot of people putting H for hydroxide. But if I look at my sheet, My hydroxide is the OH. So be careful with it. It's a common mistake. You're not the first group to make it. You will not be the last ones to make it. So cobalt 2, what's my cation? CO plus 2. Hydroxide is OH minus 1. How many hydroxides do I need? 2. CO parentheses OH close parentheses 2. Because I write it COOH2, that means I just have 1 cobalt, 1 oxygen, 2 hydrogens. If I have more than 1 polyatomic ion, I have to put them in parentheses. Class normally has 940, right? No, correctly. Yeah, 940. All right, good. We're on good time. All right, let's keep this show on the road. Let's say in a case like this, I have the formula, but I don't have the name. That's what I meant to do with my last one. I meant to give you guys the formula, not the name. I have a formula of iron iodide. Now, crazy thing is that the main 2 flavors of iron is Fe plus 2 or Fe plus 3, but I can get iron all the way down to Fe plus 1, and I can go all the way up to Fe plus 6. I have 6 different flavors of iron. How do I know which iron I'm working with? Based off a formula. I'm going to take a look at what that iron's attached to. I'm going to look at what that metal is attached to. Here, it's attached to 3 iodines. I'll flip to the next one because I think I have. We focus on what we know. What is the anion for iodine? I what? Give me 1 second. Iodine has an anion of what? 1, minus 1. I have 3 of them. And I only have 1 iron. So I have 1 iron. 1, 2, 3. Which iron am I using? Am I going to use iron plus 2 or iron plus 3 to cancel these charges out? Plus 3. Because 3 minus 1, 2, 3 equals 0. My charges cancel each other out. So if I'm writing this out, I'd write this as iron, 1, 2, 3, iodide. I focus on what I know to figure out what the cation is. I had 3 iodines. Iodine only gives me 1 anion. Your polyatomic ions only give you 1 anion. So I could put 2 and 2 together. I'm just working backwards. Giselle, you can hit the restroom. I just want to get that part out before you ran off on me. Does everybody see how I got iron 3? Let's do another one together. Oh, before we jump into the homework, I do want to jump in and say, hey, there are 2 non-transitional metals that also require Roman numerals. Tin and lead. As you see, tin and lead are both in group in group 14 underneath carbon. There's carbon, silicon, germanium, then we have tin, then we have lead. These are the only non-transitional metals that give us 2 different type of cations. They're weird. Every rule in chemistry has some exceptions. Here's our 2 exceptions. Just be aware of it when you see them on the quiz and the test. You're like, well, hey, Mr. Wiseman, SN is not in that blue section in the middle. Why am I worried about a 2 or a 4 beside it? Just be aware. Now we can focus on the homework. So I'm looking at 2 questions on the homework. I'm looking at question number 9 and question number 18. So my Cl represents chlorine. What is my anion here? Is it the copper or the chlorine? Was it? The anion, the negative charge. Chlorine. What's the anion for chlorine? Yeah, -1, right? Copper comes in a bunch of different flavors. But I only have 1 chlorine, 1 copper. What's the cation for copper here? Plus what? Plus 1. 1 minus 1 equals 0. Therefore, my name is copper, parentheses 1, chlorine or chloride? Chloride. Chloride. Those binary charges, easy to get around. Super easy to do. If not, you need to work on them. Let's see, I got nickel phosphate. So obviously I know my anion is PO4. What's the charge on phosphate? Minus what? -3, right? I can see I have 2 of those. PO4 -3. And I have 1, 2, 3 nickels. What's my anion? How many am I going to do? -3 or -6 over here? X minus what? 3 or 6? 6. Has to equal 0, right? So what has to be X for it to -6 equals 0? 6. Simple. Plus 6 plus 6. X equals 6, right? Does that make sense? It's basic math. If I have a variable I don't know, but I have the rest of the equation, I can just put it into a quick equation. I have 3 nickels. So I see up here, I have 3 of them. So I have to take this 6, now divide that by 2. Oh, sorry, divide that by 3. What's the charge on each nickel? 2. Plus 2, plus 2, plus 2. 2, 4, 6, minus 3, 6. 6 minus 6 equals 0. Therefore, I'm working with nickel 2 phosphate. So everybody see how I got nickel 2. There's a little bit of work to do. I get that. But once I find out what my anion charges are, it's a real quick fix to figure out what the cation is. Remember, my charges have to cancel each other out, right? I drew this out because I was trying to get you guys to do the math with me in my head. Do you have to do all this? No. If you find a quicker way to do it, by all means, use that way. What I'm going to be looking for in this, if I give you this on the test, where I ask you name the formula Ni3 parentheses PO4 close parentheses 2, I'm just going to be looking for nickel 2 phosphate. You should be able to identify what nickel is because if you just take a look at your periodic table, which I had, then I handed it back to somebody. I should be able to take a look at my periodic table, find Ni, right there's the name. Now, I do know that there are some elements that are close to each other, Mg, Mn. You guys are making that mistake today, which is fine. It's okay. It's a great mistake to be making. Just know that when we're talking about those transition metals, you're just going to find them here in the middle. Just be careful with it. What I want to do, guys, is I want to give you guys some time to work on those other, how many questions were there? So other 11 questions by yourself. You're going to bring this into me next class, which is a short day. Wednesday's a short day for us. We'll review it. We'll talk about them. Excuse me. And